Hello everyone, my name is Joe Dunay and I would like to show you my official unofficial network state exam solution. So the first one is about the basic functions of communication systems, definition of protocol and the process of communication based on the protocol interface concept. Please note that these bullet points are interconnecting with each other, therefore there are a lot of subparts that are connecting to the actual other parts. So I'm going to mention all those stuffs that are important. So the definition of protocol is quite simple and easy, because here you can define almost what you want, because the definition of protocol simply defines step-by-step mechanisms that how they are working, and provides a common representation format. Of course, I believe here you can say that they have to fulfill some criteria and work with the layers as well. And the process of communication-based network, here we have to define the OSI model. We have 7 layers from top to down: the application, the representation, session, transport, network, data link, and the physical layer. Because how the communication is working, when a data is being created, for example, at the application, then that will be passed down until the transport, where it will be, for example, segmented up and will get a connection. So for example, the connection is simply based on interfaces. These layers should provide a common interface, I mean not common, but an interface between the layers that they are able to communicate with each other. And for example, imagine that from top to the network layer, those layers are softwarely handled, and from the data link layer and the data link and the physical layer are handled hardwarely. So how does it look like? For example, when the network layer are passing the data to the data link layer, the data link layer consists of 2 sublayers: the logical, the LLC layer, and the physical, the hardware, the Mac layer. So the logical layer is software based. There should be an interface from the network layer that passing the data to the data link layer's logical part sublayer, and from the logical sublayer it will be placed to the hardware, of course to the network interface card, and from that then it will be passed down again. So these are the important steps. The purpose and goal of the hierarchically layered implementation of communication systems, advantages and disadvantages. Okay, so the girls did some mis mis typo here, because they wrote everywhere advantages and disadvantages, even though when there are the disadvantages. So of course the hierarchically layered implementation is considering the OSI layer is good, because it's fostering the competition that different vendors can work together, because of course they can create new network devices, new software, new hardware, or even come out with new protocol, but they have to follow strict rules, and they can work together because we know these layers, we know how they are working, and therefore it is quite good, because they can cope with it, so they can adopt to it. Of course, if it is good if we check it with an outsider's view, but if we check as the vendor's view, then this can be a disadvantage, that they have to adopt to the existing layers technology, and they cannot come out with a totally new, because then they have to change other layers, for example. And this is the other advantage of the layered architecture, that it prevents a technology change that affects other layers, but because as I said, they cannot come out with something that would require to have a new network device or something else, because that would, for example, totally change the whole network system, maybe on the earth. So I believe that's the advantages and disadvantages. The concept and structure of the protocol data unit, the process of transmission. So the protocol data unit simply defines what has been added on a given layer to the actual data and defines that packet as a whole, that what it is. So for example, we are showing it through the process of transmission, because as I said, we have these 7 layers of the OSI model, and from top to down we start to go. We have the application layer where the user, for example, would like to send an email message to another user. So in that case, the content of the email will be the data. The data will be passed down to the representation layer and to the session layer, because these are just mainly stands for the user view to make it more understandable for the human. And then it will be passed down to the transport layer, where the protocol data unit is called segments, because in this case, imagine that we are not sending a single email, but we are sending a full disk size or a full disk. That means we wouldn't just simply send some bytes, but we could send a lot of gigabytes, for example, at a time, and that would reserve the whole traffic and bandwidth, and that would cause a flow control problem. So that would simply cause a problem. So the transport layer is the solution for this, because it will segment up the data to smaller chunks. Therefore, there will be no problem by sending these data on the traffic. And of course, here, if they want, or if you want, you can talk about the transport header. The transport header is added, and within the transport header there is either TCP or UDP, which stands for the connection establishment. Okay, now we passing down the data to the network layer, where we call them as a packet, and there we have the data, the transport header, and we add the network header to it, basically the source and destination IP address that will help to identify or help the routers to where the packet should be sent. So we are talking about layer 3, we are having routers here. This will be passed down to the data link layer, where, as I said, it has 2 sublayers. It will be passed down to the LLC first, because that does the encapsulation, and then the MAC layer will pass it down to the physical layer, where, of course, at the data link layer we are calling it as a frame, because at layer 2 we are having switches, and switches are working with frames. And then the frame is passed down to the physical layer, and by bits sent to the other destination or to the other device. So this is the encapsulation process, and of course the encapsulation process is, there are 2 approaches. Either we send it to immediately to the destination, or we forward it to a router, and after that. So for example, if the data is not passed to the destination immediately but to a router, then the router will de-encapsulate up to the network layer, where it will check the destination IP address, and based on the destination IP address checks the routing table and will forward it out to a network or to a destination. Then it will re-encapsulate till the data link, and will send the bits to forward it. And if we send it to the destination, it's exactly the same, but there the computer will realize that, hey, this is our destination IP address. Therefore, we will de-encapsulate the network header, the transport header, and we will get back to the data, and we will see that, hey, it's a good email. The communication between neighboring and peer layers, I covered the neighboring now, because neighboring means, for example, when we're passing down and up the data, as I said, we need interfaces for that. For example, from network to the data link layer, there is the LLC, and then for the network interface card, which is the hardware based. The peer layers are, for example, imagine that we have host A and host B, and for example, the transport layers are communicating. Therefore, imagine that this is a TCP connect, there will be a TCP connection, and they will create a logical path before the data will be transmitted. So this is a peer-to-peer communication. Connection-oriented and connection network services and their comparison. It is quite easy that from bottom to the network layer, it's connectionless, and from the transport, it's connection oriented. Why? Because at the physical layers we are having or talking about cables, and these cables are really don't care about the source and destination. They are just sending or forwarding traffic from source A to destination B. So they don't really care whether there is a connection, they are just sending. At layer 2, at the data link layer, we are talking about nodes, because these are the switches, and the nodes are connecting nodes together to make the network. And of course the switches really don't care again, because they are just simply receiving frames and forwarding it to a destination, but they don't really care about the connection. The layer 3 networks, which are the routers of course, are the same. They are just simply forwarding packets, therefore they are not really curious about the connection. And of course here you can even mention that the layer 3 uses the IP, the Internet protocol, and that's connectionless, therefore it's connectionless. And the transport header, or the transport layer, is the one where it will actually have anything mean, because there, by using for example TCP, the connection is really important. And because from this layer to above, we are really would like to handle the sessions, therefore from this we would like to have the connection and know the connection oriented parts. So basically that's all about the first topic. If I said something wrong, then I don't really care. And don't forget to subscribe to my channel.